the inverse of a one-to-one function, I replace f of x by y, negative 3x plus 6. In step number 2, I swap the variables because now x becomes y and y becomes x. So then x equals negative 3y plus 6. In the next step, I have to solve for y. So I will subtract 6, and I'll divide by negative 3. So in final step, oh, this was 3, I'm sorry. This is final step. I just replace y by f inverse and put minus in front. So f inverse of x equals negative x minus 6 divided by 3. And this is the inverse function of negative 3x plus 6.
So now if you take f of
Yes.
inverse, you get x again.
Exactly. So because it's the inverse. So if you want to create the function composition, either direction, inner, outer, the answer is guaranteed to be plain x. It's like no deal. I give you $5 and 3 minutes later I say give it back to me. No deal. Because adding 5 and subtracting 5 are inverse operations. Nothing has changed to your portfolio by me giving you 5 and taking it away. Next question.
How about the best way to figure out the domain of the log function?
Excellent. Good. So let's take a look at something like f of x equals natural log of negative 3x plus 12. Or let's change it into a log. It doesn't matter. The answer is not going to change anything. It will not be affected. So any log applied to any expression, that expression has to be positive. When we looked at f of x equals the square root of x, we said x could be positive or 0. Here it cannot. It must be strictly positive. So negative 3x plus 12 must be strictly greater than 0. Negative 3x must be greater than negative 12. We divide both sides by negative 3. And what do I have to do every time I divide both sides of an inequality by a negative number?
You have to flip the inequality.
Exactly. From greater than to less than. So therefore, the domain of this function is negative infinity 4. Do not put a bracket. It has to be a parenthesis. Very good.
And if you were asked to graph this function,
Yes.
what are some tricks as far as what points are taken?
You can use, first of all, very good question. One, two, three, 4. That would be a vertical asymptote. You will not graph anything here. Clear? The domain is negative infinity to 4. So you can have anything on this side. Perfect. And then You can determine some points if you'd like, if that's what you want to do. That's perfect. So you can plug in 0 and then find log base 3 of 12. However, I did not teach you something because it wasn't on the list, but let me teach you now. In some calculators, and I think that the one I have here may have that option. I don't know. It's a very good question, Bob. Thank you. Some calculators, the newest ones, allow you to put in math. Let me check. Here it is. It allows you to put the base you want. Not all calculators. What I was going to show you, and I will show you anyway, is the change of base formula. Your calculator allows you to put in your base you want. Yes. So go back to math. So math. And scroll up. Don't go to the right, just scroll up. And then you will see log base. And in parentheses, this one, A. You should have it. So math is this key. Math here. This one. Math. And then go up. And you have it right here. It's A. And press enter. So it gives you the option of putting whatever you want. Not all calculators have that feature though. The old ones don't. So in that case, so you have, I didn't mean that, let me clear now. So math up, and in this case we have base 3. And in parentheses, so what I would do basically, I recommend don't do that. Just go to y equals. And in y equals, create this function with math up to log base, and then put base 3, and put in parentheses what we have. And we have is negative 3x plus 12. When you start with the first negative, it's not the operational negative, but the symbol negative. So negative 3x plus 12. And now go to second and table, because I have to change this, but you don't have to, because we already worked on this last time. Something similar. So second and table, and punching the numbers, I didn't mean to graph. I didn't want that. I just wanted to go to second and table and determine some value. And this is the incorrect graph. This graph doesn't stop here. So please do not ever copy something from the graphing calculator, just blindly copy. It's wrong. So the graph is this. And there is a vertical axis. It doesn't end here. It continues forever. So do not copy anything from the graphing calculator like this. So what I wanted was second and table, because Bob said, let's plug in some numbers, and I want to. So when I plug in 0, I get this. When I plug in 1, I get this. But when I plug in 5, what should I get? Error. It should scream at me. How dare you? Because we determined the domain. The domain is from negative infinity to
4.
Exactly. I cannot plug in. So these are good enough. I have 0, 2.2. And I have 1, 2. And I know it has to get closer and closer. I should also plug in 3 and see what happens with 3. Good. Indeed. Perfect. Excellent. So 3 at 1. So here's the graph. So this is a graph of log base 3 of negative 3x plus 12. We're able to graph it because, first of all, we determined the domain, and then we plugged it in. Now, what if you do not have access to a calculator that has that option. Till recently, I didn't have one. For example, this one does not have that feature. It looks like sophisticated. It's not at all. It doesn't have anything. Just barely minimum. So how do I change this? How do I still plug in the calculator? So log base 3 of 5 can be determined using either base 10 or natural log. It's natural log of the number over natural log of the previous base. So if I don't have the feature to put in whatever base I want, I will change this function, log base 3 of negative 3x plus 12, I will change it into natural log of negative 3x plus 12, natural log of the number of the function of the inside over natural log of 3. And I'll show you that we get the exact same numbers. Let's do that. I will create another function. This time y2, I'm not going to delete what I have. And I'm going to write at the top natural log in parentheses negative 3x plus 12. And I divide by natural log 3. And then I go back to second and table. All of those numbers will transfer. The calculator will plug in those numbers 0, 1, 5, and 3 in y2 as well. So they are the same. So we can change the base very easily if we don't have access to a calculator that allows us to. So it's not a big deal at all. You can always change any log you have into base 10 or base E. Yes, Bob, go ahead.
On YouTube, I listen a lot to this Matt tool called the Organic Chemistry.
Yes.
Computer,
Yes.
and he said that the argument of the log,
Yes.
minus 3x plus 12, you can pick some friendly points by setting that whole expression equal to 1, 0, and then the base.
Yes.
And then go back and solve.
So here's why. Here's why.
How does that work?
Excellent question. It's because we are looking for powers of the base.
Yeah.
And 0 and 1 and the base itself are powers of the base. Exactly. So let me show you a few with a simple situation. If I have f of x equals, let's say, log base 2 of x, what number should I put in here so I can get an exact answer? I can put anything I want from 0 to infinity. I can put in 1.3. I can put in 1.9. I can put in 10.3. I can put in 100.4. Any number goes from 0 to infinity, of course. The domain is 0 to infinity. But if I want to plot this function, I don't really want to plot 10.3. How on earth can I plot 10.3 and stand by it, right? And say that's 10.3. No, of course not. It's not going to be easy. So if I choose here any power of 2, like 1, like 2, like 4, like 8, like 1/2, like 1/4, like 1/8, I will get an exact answer.
And how about 0?
I cannot plug in 0.
Okay, but I asked you greater than 0.
Yes. Cannot plug in 0 because it's a parenthesis. Okay, so if I plug in 1, 2 raised to what is 1? Let's make a table so we can put all those values. Very good question, Bob. Thank you. Can you teach this class for me?
One day.
Good. Great. Okay. So I have this f of x, and I want to plug in these numbers. 1/8, 1/4, 1/2. I put them in correct order. 1, 2, 4, and 8. Okay. 2 raised to what power is 1?
0.
Excellent. 2 raised to what power is 2? Exactly. 2 raised to what power is 4? 2. 2 squared is 4. 2 raised to what power is 8? No? Very good. Awesome. 2 raised to what power is 1/2? -1. It's a fraction now, right? 2 raised to what power is 1/4? Exactly, awesome. 2 raised to what power is 1/8?
-3.
That's it.
So those are all nice easy points to graph.
Yes, sort of.
Sort of.
If you say plot 1/8 comma -3, I'll scratch my head. How do I plot 1/8? Right?
But
It's,
at least you'll see the trend of the graph.
right, exactly. Exactly. But yes, I can stand behind 1/4 comma -2. I can stand behind 1/2 comma -1. But if you want me to stand behind 1/8 comma -3, I'll say,
But you can see that that's probably like an asymptote going to 0 on that side.
exactly. Yes. So, because we know the graph. So now if I want to plot these, I'll skip the first one with your permission, right? The 1/4 -2, I can say is this. I have no problem with that. I can stand behind that point. But I don't know where to plot this, really. I will not guarantee that that is 1/8, okay, for the x value. Then for 1/2 -1, I stand behind that. For 1 comma 0, yes. For 2 comma 1, yes. For 4 comma 2, yes. And that's good enough. So yes, the idea is to plug in numbers that are powers of the base in order not to have to use a calculator. I'm not trying to avoid using a calculator, but how will I plot this? I said 10.3. Very good question. Good. Anything else you discovered from the organic chemistry?
He's very good. He's done like hundreds of hours of these videos on YouTube. And just, you never see his face. It's always like a blackboard, but he writes on it. You see this number up here. But he must drive his wife crazy because he's always doing math like every minute of the day.
Okay. Yeah, people are dedicated like that. Good. What are we doing next? Next question. Are we going to be ready for this final on Tuesday? I'm sorry.